Hello and welcome to this video which will show you how to cross-compile Qt5 for the Raspberry Pi 3 and allow you to do remote debugging. So you can upload your code to the Pi and debug it with one single click from Qt Creator. Okay, let's get started. You'll want to open up the blog post here. Link is in the description. So let's start off by downloading the Raspberry Pi latest image. There's a direct download link here. I've already downloaded that. You'll also need to go and get Elena Etcher if you don't have it already. So let's open that up. Here we go. So you want to locate the Raspberry Pi file. It's okay to give it the zip, it'll decompress it. Select your micro SD card and click flash. We'll have to authorize it. Now this will take a little while to decompress and flash. So while that's doing that, we might as well go and download LUbuntu, which is what I recommend for the Linux virtual machine that you'll need later, because it might take a little while to download. There's a direct download link just here, and you'll also need a virtualization software. VirtualBox works well, but you can also use VMware Player or whatever you like. As you can see, I've already got LUbuntu. You want the alternate download, which is smaller, comes with less crap that we won't be needing. So go and download VirtualBox if you don't have it already, and LUbuntu, and we'll wait for this to flash. Okay, so now that the Raspberry Pi operating system has been burned onto the SD card, I put the SD card in the Pi, connected up Ethernet HDMI to a video capture card, and I'm going to power it up now. Okay, you'll see the Pi booting up. Apologies for my terrible quality USB capture card. Yep, so you see the Pi will resize the file system, so it'll take a couple of minutes just for it to reboot and do that. Okay, so now the Pi is booting up for the first time. Now what we want to do is go through the setup menu, choose your location and click next. Okay, and we want to choose a password. Now I'm just going to use PiDev because it's easy to remember. You're going to be typing this in a few times and I'm going to be wiping the SD card after I'm done, but you might want to use something more secure. Just bear in mind that you'll be using this password a fair few times. Now I do have a black border. Now if you don't have an Ethernet connection, here is where you would connect to a Wi-Fi network, but I do have Ethernet so I don't need to use Wi-Fi. So I'm going to click skip and click next to update the software. Now this might take a little while, so just be patient while it installs the updates. Now while this is going on, I'm going to disable Bluetooth and Wi-Fi, so just left click on Bluetooth, turn off, left click on the network and turn off wireless. Okay, so now the update is complete, click OK. Now before clicking restart, we want to click on the Pi icon, top left, go to Preferences, Raspberry Pi Configuration, and come over to the Interfaces tab and enable SSH. Secure shell, and then click OK. This will allow us to remotely log in without actually having to be at the Pi, which will be useful later. Now we can click restart, and that should be, for a while, the last we'll need for physical access to the Pi. Okay, so now that the Pi is installed and ready, we need to create the Linux virtual machine. For this I'll be using Oracle's VirtualBox software, which is free and works well. So open that up, click New. I'm going to call this LUbuntu PiDev. Yeah, Linux Ubuntu 64-bit. I'm going to give it 8 gig of RAM. Just make sure you have enough system RAM to do this. Somewhere around half of your actual maximum RAM is fine. 4 gig should be enough. Create a new virtual hard disk. VDI, yep, dynamically allocated. And I'm going to allow a maximum of 60 gig. 40 gig should do fine, but it's best to allow a bit of headroom. And as it's dynamically allocated, it won't eat up the hard drive space. So open up the settings. We want to go to Advanced, Shared Clipboard, Bidirectional, System. I'm going to give it 8 CPU cores or threads because I have 16 available. About half of your maximum is advisable. Enable PAE. Now for the disk, we want to choose a file. As you see, I've already found the LUbuntu, which is in my downloads folder. Click OK, click Start. I'll just show you the messages that come up. So yep, we want to start on there. Close that. Yep. Just press enter to go through the menus. I'm using English. United Kingdom. Again, you want to select the keyboard that you're using. Now just be patient while it goes through configuring everything. It will take a few minutes, but it will get there eventually. Now for hostname, I'm just going to choose PyDev, username PyDev, password PyDev. You have to confirm to use a weak password. Yep, Europe London, looks good to me. And now just select guided, use entire disk. That's the disk we want to use. Write changes to disk, yes. Now just sit back and wait while it installs. It will take 10 to 15 minutes depending on your internet connections. It will go and do updates as well. Just be patient and wait for it to finish. Okay, now just press enter to select no proxy unless you are using one, and it'll go and download the updates. Okay, and select yes to install grub to the master bootloader. And yes to set the system time to UTC. Okay, now installation is finished, so click continue. Okay, and now it should reboot into LUbuntu. Right, so log in with the password you chose earlier, PyDev in my case. Now, all we need to do is go to the main menu, System Tools, and LX Terminal. I'm going to drag it down here, just in between these two other icons. Now, we need to run the following commands to do a full update. Now, can I paste into this virtual machine? No, not yet. That's fine. We'll just have to type out the command by hand. So it's sudo apt update ampersand ampersand sudo apt full dash upgrade dash y. Enter and your password. The dash y just says yes, rather than having to confirm again later. Okay, when that finishes, we want to install the following commands. We're going to type sudo apt install open SSH server. You can use tab to autocomplete. We want net tools, just so we can run ifconfig to get the IP address. And as I'm running in a virtual machine, I'm also going to get open VM tools. You can skip that if you're running this native on your PC. Go and install that. Okay, now once that's done, what we want to do is reboot. So type sudo reboot. That will apply all of our changes and bring up the SSH server. Now, we won't actually need to open the graphical interface to our virtual machine anymore. We can use SSH. So I'm going to do that by opening up a terminal here. Now, the one thing we will need, if we log into our virtual machine again, is the IP address. So if we run ipconfig, we'll see that's the IP address of our virtual machine. So if I type ssh pydev, which is the username, at the IP address, which is 10.0.2.15. Now an issue might come into here is if you're not able to actually connect to your virtual machine. Now that's probably because we have a virtual abridged network adapter. So I'm going to shut down the virtual machine with sudo shutdown now, or you can do it through the menu, either way. Wait for that shutdown, go to the settings, network, and attached to, we want to change that to bridged adapter. That way it will be on the same network. Now I'm going to start this in detachable start, so I can close the window when I'm done. Okay, and when that's come up, log in, open our terminal, ifconfig, see our IP address is now changed. So if I find my terminal again, here, and now I do 10.0.69.154, just double check that, 164, measure twice, cut once. There we go, and it's going to want to confirm the host, because this is the first time we've SSH'd into it. And we enter the password, and now we've SSH'd from our host machine into our virtual machine. Now, I'm just going to exit out, and I'm going to run the command ssh copy ID, again using tab to autocomplete, with the username at the IP address 164. Now what this will do, prompted for your password, and the first time you run this you'll be prompted to confirm the host. What this will do is copy my public key into the virtual machine, which will allow me to log in just by running the SSH command with no password. Okay, so once we've got that done, now following on from our instructions, and we've set up our Raspberry Pi, down, and we also want to be able to SSH into our Raspberry Pi. So I'm going to open a terminal for that. Let's drag that just there. So I want to SSH into Pi at the IP address of my Pi, which is 69.50. Now I've just formatted the Pi, so I'm going to have to modify my hosts file, which you simply do with nano and the name of the file. Now I can SSH in, and it thinks it's new. Pi dev. Okay, and I'm going to run the same command as before. SSH copy ID Pi at 69.50. Pi dev for the password. Now I can log into the Pi without a password. Wonderful. So what we want to do, now that we've SSH'd in, on the Pi we need to edit a config file, sources.list. Now I'm on Linux, so I'm able to use middle click to just highlight and paste. So we want to edit this file and just take off this comment, the hash symbol, to enable the deb source repository. And then we exit from nano with Control X and then Y and then enter. Okay, so now we've done that. Now we want to do a full update on the Pi, which may do nothing as we've already done a Raspberry Pi update, but it's good practice to do. Okay, we see 0 packages have been installed and upgraded. If some had been installed, what you'd want to do is sudo reboot, and then once the Pi is booted back up, SSH in again. But we don't need to do that. What we do need to do is install all of these. Now these are libraries that we will need to use to build the software for the Pi later. So just go through, install all of these one by one, and run sudo rpi update again at the end. And then when you're finished, run sudo reboot. Okay, so now we've added the build dependency for Qt4. Now we want to add the build dependency for Qt5. Now while this is going on, in parallel we can start some of the setup in the virtual machine. So if we scroll down a little bit, you'll see synchronize the Pi and Linux VM, and this signifies that we're running commands on the development VM. Now we should have already just done a full upgrade and update, but just to be sure, let's run that again. Now we see that command's finished, so that was Qt5, so the next one is this line here. So we just paste that in. Okay, and now we need to make a directory, which is where the binary libraries will go, and then we want to own it, and run the Pi update. And when prompted, just press Y. Okay, now to move on with our virtual machine. So we've done an upgrade and update. That's just going to remove one. I'm just on the Pi, press yes. Alright, so now we want to make our Raspberry directory and enter into it. And we also need to install Git Python and Python 3 if they're not already. Now the Raspberry directory is going to be used to hold our sysroot, which is a copy of a lot of the files from the Pi, as well as all of our development tools, and where we will be building Qt. So we want to clone the Raspberry Pi development tools, Okay, and the Pi is done. So we'll go ahead and do a reboot. And now our Pi is coming back up. We can SSH back into it. Okay, and now we've finished that. We want to create our sysroot folder and user and opt underneath it with that command. And because we're going to be typing in the Pi's IP address quite a few times, it's nice to create an environment variable for it. So the IP address for me is 10.0.69.50. Now, if you don't already have a key created, you'll want to run ssh keygen in the virtual machine. Just press enter 3 times, and that will create the public-private key pair, allowing you to SSH into the Raspberry Pi. Now with that done, we can copy across the SSH credentials, type YES, press enter, and the password for the Pi. Okay, now we can start synchronizing files from the Pi over to the sysroot we just created. So just copy these commands in one by one. And note that you won't have to type in the Pi's IP address because we have that environment variable Pi IP. Now these will take a little while to do, so grab yourself a drink and wait for them to finish. Now while this is going on, it might be a good idea to go and download the Qt installer, which we will be needing later. So we can do that with this wget command. Now I'm just going to open up yet another terminal. That's a big terminal. Shrink it down a bit. So we're going to SSH back into pydev at 10.0.69.164. Wait. Now we'll change directory into downloads and we'll go and get the Qt installer. Note that we have to use 5.12.3. Now this is the version of Qt that I found to be most reliable with the Raspberry Pi. 5.12 is the long-term support version of Qt. I will be trying with later and the latest versions of 5.12 and also 5.15, which is the latest build of Qt. Now we can just leave that downloading in the background for when we need it later. Okay, now we've finished doing lib and sysroot, so we want to do user include. Paste that over. Okay, so now that's finished. We want to do user lib in this terminal. Okay, now the Qt installer is finished downloading. I'm just going to mark that as executable with chmod +x and the name of the file. And we don't run it yet, and we will have to run that from the graphical interface of the virtual machine. There are some libraries to install first. Okay, so now that one's finished, and just to check the up arrow, that was user. So now the last one to do is opt. Okay, now that's finished. We need to fix the symbolic links so that it works on the sysroot that we've created. Now to do that, we need to go and get a script, which is available here. So just go and download that, and then we need to mark it as executable. Like so. And now we need to run it and give it the folder of our sysroot. Okay, job done. So now we can go ahead and install some libraries and programs that we'll need to actually run the Qt installer. Okay, and the next one. And the next one. And then finally this big long thing. Okay, so now that's finished, we can actually install Qt. So let's navigate to the downloads folder and execute the installer. Now unfortunately we have to log in, which is pretty horrible, but hey. So you'll have to go and create an account with Qt, which you can do here, but you have to verify the email address. Okay, so once you've logged in, click next. Yep, that's a good place to put Qt. Now this bit is important. We need to make sure that you have all of these following installed. We need the sources, because we're going to be building Qt and using the source files, we want the web engine and WebGL. So make sure that these tick boxes are the same as these here. And then click Next, sign your life away, and install. Okay, so now that's all done. Click Next. And we don't want to launch Qt Creator, the IDE, just yet, so untick that and click Finish. Now we need to go back to our terminal. We've got a little bit more work to do. So we need to cd into Raspberry, but we're already in there, so we can skip that. Now we need to go and get Qt. Again, I know, this is to build it from scratch. And this might take a little while, because it is quite big. Okay, now that's done, we need to fix a make spec for the Raspberry Pi 3 because unfortunately there is a bug in the one that comes by default, but it's very straightforward to do. I've copied my own up onto GitHub, so we'll just clone my fixed one and I'll show you what the differences are. So if we go into, we use Nano to look at the broken one, which is in Qt base, make specs, devices, Raspberry Pi 3, QMake.conf. Now this is the problem. Look at this, 2 equal signs, and again, not very good. And we also need to put something in here, Qt sysroot. So I'll exit out of that, Control X, and then we just run this command here, which will overwrite the broken make spec with the correct make spec. There we are, done. Now if I rerun Nano, you can see the fix has been applied. We have the Qt sysroot in first, and we fix those double equal signs. So we can exit out of that. Now we need to cd into Qt base. Now the fun begins. Now this horrible big long command doesn't build Qt, it configures, .configure, it configures Qt ready for building with all of the options that we want. Graphics drivers, we want to cross-compile, here's our toolchain, here's our compiler, here's our sysroot, we want open source, confirm the license, make libraries. So click enter and go and grab another cup of coffee or tea because it's going to take a little while. Okay, so we finished configuring Qt and we are now ready to build. Now it's very important that you read the messages that come out of Qt configure. Make sure it says Qt is now configured for building, just run make. Now we don't type make, we have to type sudo make. The reason for that is because we're using files which are not owned by us or our user, they were copied across, so we need to use sudo so that we can write to them. And we also want to specify the number of CPU threads that make is allowed to use to compile. Now on my virtual machine that's 8. Now your mileage may vary. If you forget, the easiest way to check is to run htop and you can see there are 8 CPU threads available. So press Q to exit that. So sudo make -j8. Now this is going to take quite a while because we are building the whole of Qt and all of its libraries from source for the Raspberry Pi. So we're cross-compiling the whole of Qt and we're also building QMake, which is Qt's make system, which we will need later. Okay, now that's all done. The last thing we have to do is install it to the sysroot we created earlier with sudo make install. Now again, we have to use sudo because of the permissions of the files. Now this will just copy across all of the libraries that we've just built into our sysroot folder. Okay, now that's done. We cd up to Raspberry and we synchronize across the libraries which we have just built using this command here. Same as before, first we synchronize them across to our development machine, now we're going to synchronize them back to the Pi. As you can see, there's a load of QT5 libraries that have all been synced across. Now that that's done, we need to SSH back into our Raspberry Pi. So let me just find the terminal that I need. Pi at Raspberry Pi, that sounds like it. So we need to run this command here, which will basically tell the Raspberry Pi about all of our lovely new libraries that we have, and then sudo load config to load that new config. Okay, we are now ready to build and run some examples. So from our development machine, let's try the analog clock example. So we'll cd into that example folder, and then we run the QMake that we have just built. Okay, QMake has created its little stash file, so we are now ready to build with make J8 or the number of virtual CPUs that you have. Okay, so now that's finished, we can copy across the analog clock example to our Raspberry Pi, and let's see if it runs. And I can confirm on my Raspberry Pi I have an analog clock running, which means, and if you do too, congratulations, you've just managed to cross-compile code and run it on the Raspberry Pi. But we're not done quite yet. We still have to set up Qt Creator and debugging. Now, one thing to note here is some programs, yours or Qt's examples, will depend on other Qt modules, such as SVG or networks or various things like that. Now, these modules will need to be checked out and built and copied across in the same method that we did before, except we'll just be building one module rather than the whole of Qt. So let's crack on and get debugging working. Now, to do this, we need to install GDB multi-architecture. So we install that on our development machine with this command, and we install GDB server on the Raspberry Pi, and this will allow us to remotely debug applications from Qt Creator. Okay, so now we need to configure Qt Creator for building with the compilers and the toolchain that we've just set up. Now, first off, if you're using VirtualBox, you want to install the Guest Editions CD. There we go. We want to run the vbox linux editions.run. So let's see if I can open a terminal here. Yes, I can. So I'll do sudo vbox linux editions. This will allow us to use copy paste and resize the window. Okay, so now that's done, we have to reboot to apply that. So just use sudo reboot, or you can use the menus if you prefer. Okay, so we'll let that boot back up. Now that we've rebooted, we'll log in. Okay, so now we have vbox guest editions installed. We can go ahead and resize and make this window a little bit bigger and open up Qt Creator. Now what we want to do is go Tools, Options, and first off, we want to go to Devices down in the left sidebar. So you want to add a new generic Linux device, and I'm just going to call this devpi3. Put in the IP address of the machine and the username, which is Pi for a Raspberry Pi, and you can see it's already found my private key. If you haven't run ssh-keygen yet, from a terminal within this virtual machine, you'll need to do so to generate this public and private key pair, which will allow you to connect to the Pi. As you can see, it's just tested file transfer and that it can connect to the Pi. Okay, so now we've done that, we want to go over to kits and Qt versions and add. We want to locate the QMake file that we produced earlier, which is stored in home pydev raspi qt5 bin QMake. Okay, now I'm going to call this rpi3 so we know what version of Qt we're using. Click apply, then go to compilers. We want to add a Gcc C compiler. So go to browse. Now this one is a horrible long path, so we have to go to home, raspi, tools, arm, bcm, blah blah blah, gcc, linaro, arm linux, blah blah blah, raspberry-x64, and then bin, and then arm linux gcc. There. And I'm going to call that pi3 GCC. Okay, now we're going to add a GCC C++. I'm going to call that pi3 G++. This is the C++ compiler. So, and that's in the same place, blah blah blah, bin, arm linux, G++. Okay, and we need the debugger, and this is multi-arch that we installed earlier, so I'm going to call that gdb multi-arch, and the path to that is in root user bin, user bin gdb multi-arch, come down to gdb multi-arch and click apply. Now I'm going to come over to the kits and add. This is going to be rpi free, and I'm just going to steal this string here, which will just print the current version of Qt. rpi free gcc. Okay, so we want to select generic Linux device. It's already found the device. Make that a little bit bigger. Okay, so we want Pi free GCC, Pi free G++, we want GDB multi-arch. Make sure to select Qt version, rpi free, and the QTMake spec is a bit long, so I'm going to copy and paste it by using ls and tab to help me out. So home, pydev, raspi, qt base, make specs, devices, linux dash, raspi, free, G++, and QMake should be in there. Now, I believe we just have to give it the path. So I'll just highlight that, copy it, and paste it in there. And for the sysroot, that is in home raspi sysroot. Okay, that should all be configured now. Everything looks good. Okay, so let's create a console application, as we're doing here. Let's put it in Qt projects. So we'll put it in there. And again, this is debug test. We want to use QMake. I'm going to select both kits. No version control needed. So the Raspberry Pi kit in debug mode. Now, one thing we need to do is change the target path from opt to home/pi/that and get rid of the bin. That just means it's going to create a folder called target, which is debug test, and it's going to put the binary straight in there. So nice and straightforward. Let's just check that it runs. It helps if you save the project file. You'll probably do it this time. That's a strange error, but okay, fair enough. Now, just to print something out, we're going to include qdebug and I'm going to do quick hello world. And now if I run that, it prints hello world. Wonderful. Now, what about debugging, the important part? So, can we copy and paste? No, we can't. That's fine. What I'll do for this example is create an int called myInt. I'll set it to 0. I'll then increment my int. I'm using control space for the autocomplete, by the way. Then I'll do my int plus equal 5. Now, if I whack a breakpoint just here by clicking in the left margin where the line numbers are, if I now run this in the debugger, and I maximize this window, you see we can inspect the myInt variable, which is currently equal to 0. Now we want to use the step into command, which will basically run every step of the application as it would usually be run. So I can now step one step at a time, and it will increment myInt, and then it will add 5 to it. So we can see myInt has now gone up to 6. Congratulations, that is remote debugging on the Raspberry Pi 3. And we can exit the debug session, closing stop just there, and going back to normal edit mode, and removing our breakpoint. Now we can also run the same code on the PC, rather than remotely. So if I run that, it'll just print hello world there. And we'll stop that. So there we go. Now, one other problem you might have when using Qt and the Raspberry Pi is some of the modules that I talked about earlier. So for example, if I try and run the chat server, let's run that one. We'll configure it for both. Again, we'll change this to be, as the same as our previous example, target path equals home pi example, and we can put it in there. That should be fine. If I save that, notice the build buttons will grey out while QMake is running. That's what that's doing in the background there. Now, if I try select the Raspberry Pi 3, Qt WebSockets not available. So what we will have to do, if we scroll up in the guide, so here's an example for Qt SVG. There we go. So you go. Now we want the Qt modules. Oh, here we are, /Qt. So if we go to /Qt, so we can see, for example, we had Qt SVG, but we want Qt WebSockets. So what do we have to do? We have to find WebSockets, and it's just Qt WebSockets. Now, it'd be useful to be able to SSH into our development machine. So we need to cd into Raspberry. We need to git clone Qt WebSockets.git -b for branch. This is very important. We need to get the same version as the Qt base we're using, which is 5.12.3, not 13. Okay, now that's downloaded, we can cd into Qt WebSockets, and we can run QMake. Now we need to run sudo make j, 8 in my case, number of threads that I have. You may have less or more. So we'll let that compile. We'll do sudo make install, and then we'll cd back up to Raspberry, and now we will do rsync to synchronize those changes across. We need to re-export the IP address local variable, like so. And then we've synced across. Okay, so now that we've synced that across, we also need to run these two commands. So we've still SSH'd into our Pi, so I'll select and run that, and sudo load config. Okay, now let's see what happens when we try and run. Web channel. There's another one. Qt web channel. Okay, so we'll just go through the exact same process as before. Git clone Qt web channel. Qt web channel. Run QMake. Sudo make j8, sudo make install, and cd up Now we want to rsync, and I'll just load in that config as before. So now if I hit Control-Shift-B to rebuild all, that's built. Let's try running it. Some files could not be transferred. I'll tell you what, let's try running it like that. Let's just go back to our initial example and see what the command is they used in the make file, or rather the QMake file, the project file. Yep. So let's do $, open curly brace, target, close curly brace. Save that and run. Now it looks like it's running. Now we should get a, there we go, keep alive check. That means that that application is running remotely on the Pi. And not only that, but it's using these Qt modules. It's using WebSockets and Web Channel, which are two distinct Qt modules that we have built and added into or onto the Raspberry Pi. And here they're included here. So that is the way that you need to add Qt modules. You can find the module that you want to use, WebKit 509, whatever it is that you want to use, clone it into the Raspberry directory. So you can see we have Qt base, Web Channel and WebSockets. CD into it once you've cloned it, and make sure to use the correct git clone with -b for branch 5.12.3. Then run QMake. Then run sudo make, because we're modifying files which aren't owned by our local user in the virtual machine, and sudo make install, and then cd backup to the Raspberry directory out of whichever subdirectory we're in. So we back up to Raspberry, and then we can rsync the QT5Pi directory over to the Raspberry Pi. And don't also forget to run these two commands to load that new config into the Pi. Wonderful, that should be everything that you need to get up and running with remote debugging on the Raspberry Pi. Now one thing to note, if you build and try and run a GUI program, it won't work because you can't run a GUI from a terminal like this. You can do remote execution of a GUI and have it appear, but that's a bit beyond the scope of this video. What you can do, however, is build, run. It'll fail, that's fine, just quit it out, and the program is on the remote station. Or you can use rsync like we did before, so you can just rebuild it, and if we go show containing folder, that would be built in this folder. So here's the executable. So if I try and execute this, it didn't work. Wrong architecture. But you can use rsync or SCP, secure copy, to copy just that executable across, as we did with the initial analog clock example. Copy it across to somewhere on the Raspberry Pi and then run it from the Raspberry Pi that way. Well, thank you very much for watching. I hope this was helpful to you. Please leave a comment down below if you had any issues or if there's something you think I could have done better. I will be trying to expand this with Qt 5.12.9, which I believe is the latest, and also 5.15. So watch this space and see how that goes. Thank you very much.